Hello and welcome to Metra AVTech Tips. I'm Brent.
I'm Adam.
And it's Wednesday afternoon.
Yes, it is.
And what do we do on Wednesday, Adam?
Well, we talk about stuff.
And that's what we're going to do today. So what is today's show, Adam?
Well, today we're talking about how to design an HDMI, or how to design a system ready for HDMI 2.1.
Wow, you're ambitious.
Yes, I understand that. And the reason that we're doing this is not because, look, here's the thing. I was really worried about today's episode, specifically because we talk about HDMI a lot. And I don't think that's necessarily a bad thing because, of course, we are in HDMI.
Our world is
HDMI. However, specifically, we recently have been talking about HDMI 2.1 a lot.
It's our future.
It is our future, and that's exactly what it comes down to. It's no longer a matter of, will it, won't it happen, speculation of what it could do or what it could be. It's here. And one of the things that I want to talk about is, what is HDMI 2.1? How is it working? What's it going to do? And all of this good stuff together. And just all around, what are we going to run into as a problem?
Well, let me ask you the important question.
Like that.
Are you better prepped for this than doing math?
The nice thing about today's episode, there's no math involved with today's episode.
Awesome.
So I think I'm okay.
Before we get into today's episode, let's do your usual housekeeping agendas.
Yes. So first off, of course, like, share, subscribe, hit that little bell notification to let you know whenever we do go live, which of course is every Wednesday at 3 p.m. And of course, right now, as things are progressing, I know that there's a lot of rumors going around out there about what's happening with Cydia. At this very moment, there are quite a few of the bigger entities that have decided to go ahead and pull. As it stands right now, we are still going. And
at 30,
it's 3:03, and you're not allowed to make any more comments about that. But truth be told, we are still going. We are still planning on being there. We are still planning on having a great time. So please, if you're still planning on going, let us know that you're still going. Or if you're planning on not going, let us know that as well, because that's good information for us to have anyways. It helps us make decisions on our side.
I'm just noticing my red looks much better on video than your red.
Well, I did think about that, because this red is more of like a burgundy. Is burgundy the right word for this?
I'm not sure. I'm just saying, because just looking at our monitor.
It's almost like
which is not color correct.
No, it's not. Yeah, that monitor is all sorts of screwed up.
You could look better than I do.
Yeah, of course. Now, of course, everybody who is watching today's episode, if you have questions about whatever it is that we're talking about today, please leave it over here in the chat section on the side, or if you are watching this after the fact, leave it down in the comment section below.
Okay, so
yeah,
let's get into HDMI 2.1.
Right.
Because it's hot in here today.
It is very hot today. Yeah, unfortunately, that's another thing. Our AC's broke. So, but we're here for it. We're here to, get it out there, and sweltering heat be damned. Okay, so.
Did you just say that?
I did just say that.
I know there's an HR report coming there somewhere.
Somewhere in there. Okay, so part number one of what we need to do is, first off, we need to do a recap of what is and what is not HDMI 2.1. So, Brent, what is HDMI 2.1?
It's the one that came after HDMI 2.0.
Right.
And slightly before HDMI 2.2.
Or
3 or
whatever they decide to jump to on the next one.
What it really is a fairly substantial jump.
Yes.
Fairly substantial jump in feature set capabilities. We tend to get wrapped up in 8K or 48 or numbers that aren't always really useful. And one of the things that I know we're going to discuss are the different feature sets involved in 2.1.
Right.
And as we discussed, mostly you, thank you, in our math class for HDMI bandwidth.
Which I did get the math right on that one.
It's understanding just because all the feature sets are available, they're not available at the same time.
So really, HDMI 2.1 isn't necessarily a standard. It's more of a set of features, right? It's just it's an upgrade of what features are available to be used by sources and displays.
It's a bucket of tools.
Right. So,
and how many tools can you hold in your hand at one time?
Right. Yeah. Well, and depending on what, if you go back and watch the bandwidth episode, you'll know that answer. Oh, and also, for everybody wondering, that bandwidth calculator is still available on the link on that video. So if you go out down into the description on that video, it's still there. And we're working on actually building it into our website too. So,
awesome.
Yeah, so we're super excited about that. So with HDMI 2.1,
appreciate you filling me in on that beforehand.
Yeah, of course. Yeah, no. See, I like to give you surprises along the way. I think you handle it better that way. If I don't give you time to prepare for it, I think we have a better episode.
Then we're in great shape today.
Oh, we're great. Okay, so what are some of the big features of HDMI 2.1?
Well, the biggest thing that HDMI claims is the ability to go to 8K, which you could actually do if your TV did under 2.0, but a very stripped down version of it.
Yeah, what?
You could actually get really stripped down 8K at 8-bit and 420 at the very edge of the 18.
Now, are we talking like bandwidth capabilities?
Right,
yes,
right.
Bandwidth-wise, you
but
could.
But the TV couldn't do it.
No, yeah,
But as far as bandwidth, and that's the thing is people automatically assume HDMI means 48, or
no.
2.1, excuse me, means 48.
Right.
Number one, it doesn't.
Right.
It is a theoretical shell of 48 gig.
Yes.
Theoretical
Yes.
shell of 48 gig.
Yes.
The question is, what are we going to fill that shell up with?
So we got a 5-pound bucket and we got 10 pounds worth of features.
Well, in the old days, we refer to that as 2 tons of fertilizer in a 1-ton truck.
Yes. So
that's kind of where we're at.
Yeah.
And that's why feature sets are very important, because if you look at your feature sets, and again, back to your math class on the bandwidth, you can get 8K, and you can get, or you may want, let's say here are options.
That's what it is.
You got an 8K option, you've got a 24, 30, 60, 120 option. So we got 1080, 4K, and 8K.
Right.
Then you've got 420, 422, 444 options.
Right.
Then you've got 8-bit, 10-bit, 12-bit, 14-bit, and eventually
16-bit.
16-bit,
right,
as it currently stands.
Right.
All of these are options. Now, much like a loaded up Explorer and my wallet, the two don't match.
Yep.
My wallet does not support the fancy ST high performance 20-inch wheel, dual sunroof Explorer.
Well, no, you get paid the big bucks for being on this show, right? They pay you the same that they pay me, right?
Wait. You're getting paid?
Anyways.
Really?
Yeah. Wow. Good. Michael says he's going to be at CEDIA. He says all things
Which
being
Michael's
equal. Michael Heiss. He says all things being equal, I'll be at CEDIA. Look for the jacket and my new Sarnoff test pattern tie. Sarnoff. Is that
test
like a
pattern tie?
Is Sarnoff? Oh, I want to look that up now and see if that's something.
Is that the fancy one from the 50s, early 60s with the Indian head on it?
Test pattern visualizer. Let's go to images and see what this looks like. Oh, interesting. Okay.
Okay, yeah, so that's the old...
Now that's something... Oh, interesting. Sarnoff Visualizer HD test pattern.
Okay, so which one's the test pattern?
Yeah, I'm kind of curious now.
Okay, so thank you, Michael.
Yeah. No,
it's sidetracked us completely with that development.
It's not the one with the Indian head.
Okay.
No, it's
this
one here. It's this one here with the all the different things. It's got the picture of the three women, the different color patterns, and then it's got the test pattern and everything else around it.
Which is used by ASF, as I recall.
Yeah. Very cool. Very cool.
Okay, so
anyways,
back to where were we?
We were talking about
feature sets.
Feature sets, yeah. So some of the big ones, of course, we talked about, 8K, 4K 120, or did you mention 4K 120
I did.
yet? Okay,
I
4K
said
120.
You can do 1080, 4K, 8K.
Right.
24, 30, 60, 120.
Right.
422, 420, 422, and 444, and 8, 10, 12, 14, 16-bit. But you can't do all of them.
Right. So I would call those features, let's do this. I would say that those features are additive features. Then we have new features now, which are more subtractive features. And this is one thing that's kind of...
Okay, now, see, you got me intrigued now.
Right? So, okay, so going back to the episode for the bandwidth, right? One of the things that we talked about is the math of doing the bandwidth is multiplied, because we have pixels upon pixels upon pixels upon pixels, and each individual pixel has all this data. The pixel next to it can also have its own data, or if it's being subsampled, it does whatever. So that's my additive or multiplied band or feature sets, right? So where they add bandwidth. Oh, it's not that one either. Okay. Anyways, okay. I'll be looking for you out there at the show. We'll
send
see
us
which
a
one it is.
photo.
We'll
Get
take
us
it. We'll take
excited.
send us a photo of it. So those are kind of like additive features because they add bandwidth to the overall HDMI connection, right?
Okay.
So if you have 1080, 480, 720, 1080, 4K, 8K, and then as we move on into the future, we have 10K and whatever else. That's adding more pixels, right? So we're adding more bandwidth requirements, right? So then we have the bit depth, and the bit depth we have the frame rate. So we have 24
Refresh,
frames, the 50 frames, 60 frames, 120 frames.
In Europe?
Well, even here in the US, some stuff still uses it. But yeah, so the 24, 30, 50, 60, and then now we're up into the 120 for HDMI, right? But
gaming,
again,
yes.
for gaming, and with those again are additive because it's adding more bandwidth the bigger number that you have, right? So then after that, then we've got our bit depth. We have 8-bit, 10-bit, 12-bit, 14-bit, 16-bit. Is 14-bit a real thing? Is anything use 14-bit?
Right now, really nothing is above 10.
Right.
That's a good question for Michael because he probably would know.
Michael, does anything use 14-bit out
Or
there?
12?
Are there any not test patterns, but are they in like mastering
Content?
systems or content that they use 14-bit? Let us know in the comments. But again, those are additive features, right? If you have an 8-bit, it's really low because it's just an 8-bit word. But you go to 10-bit, and now we're adding more information
so
per
while we're
pixel per
discussing
frame.
that,
right?
explain, because they may not have seen this in the past.
Okay.
Explain the difference between an 8-bit and a 10-bit word. Because this is very important for what we do.
Actually, I'm going to turn this back over to you because you do this better than I do. The
was trying
8-bit
to
and
dump
10-bit.
all the
I know,
work on
I
you.
know, exactly. Yeah, you were trying to, but it's not going to work because this one is you. Let's see, let me do this here. We're going to hit this button there. Haha. Are we playing Hangman?
We kind of sort of are.
Okay.
Now, in the old days, this would have been a dip switch.
Yep.
We've all seen 8-position dip switches.
Yep.
And an 8-position dip switch gives you how many options?
8 times 8, right?
It's 256.
Okay, 256. Yes. Okay.
Options.
Yep.
And it's actually 0 to 255 because 0
Is a value.
is a value.
Yes.
And so each of the dip switches has a numerical value. So you got 1, 2, 4, 8, 16, 32, 64, and 128. And if you add all of those up, what do you get?
256.
Exactly.
Right.
Now, the 10-bit adds to that 256 and 512. Now, what this does for you is it gives you more color options, because how this simply works is whether or not the switch is on or off turns that numerical value on.
Right.
So it's kind of like an abacus.
Right. It's you're counting in binary at that point, correct?
Yes.
So when you have 256, so we have these here for 256, right?
Right.
So what we're doing is we're using all of these together to give us a numeric value for a color point, right?
Yes.
Now, and that's also, that color point is also.
And if you've done Paint Shop,
Yep. Yeah.
when you look at the side, the RGB, it gives you 0 to 255
Yep.
for color.
Right. So yeah, Paint Shop or Photoshop.
Yeah.
Photoshop. So you can do,
That's Microsoft Paint and Photoshop.
Oh, there you go. Yeah, that's what it is.
I'm an old man.
Paint Shop. There you go. who are you calling a dip? So you have 256, 1 through 128. So you have 256 positions or values.
Values. Now,
Yep.
and then realize that it's 0 to 256, and here's why.
Or 255.
255. And here's why, because these are all switches, high and low.
Right. Do you know how to count in binary? I know how to count in binary. I learned how to do it.
I'm proud of you.
Yeah.
So let's say this switch is up. This switch is down.
Right.
This switch is down. This switch is up, down, down, and up. What is that numerical value?
So, I have to do it by hand. I haven't been able to do that. So I can't go that high up yet.
Wait a minute.
Hang on.
Do
I
you
don't
need
have
to
enough
take your shoes
toes.
off?
I do, because we have 8 points. I need
simple.
8 things.
1 plus 8 is 9, plus 16 is 33, plus 128 is 158, plus 3, 161.
161. So, okay. Is that how you do that?
Yes.
Okay.
Or you could go backwards. Honestly, a lot of people do it backwards because the last one's an odd digit.
So it's
and when
easy.
you stay in evens.
And you're starting with the bigger number and adding the smaller numbers to it. Oh, interesting.
Now, the thing to remember is this is handled with each of the 3 primary colors, red, green, and blue.
Right.
Until we get to HDMI 2.1 because it's not 3 separate channels. It gets a little bit more tricky there. But,
yeah.
So we're going to now add these 2 additional channels.
Right.
And what these are all about is color depth.
Yeah, it's adding more.
How many colors you have.
Right.
So if we've got an 8-bit color option, how many colors do we have, red, green, and blue? How many options?
Come
on. Standard 8-bit computer monitor. How many colors? Has been this way since the early, well, forever.
Well, it's 256 plus 256 plus 256, right?
No, it's 256 times 256 times 256.
Okay.
Which equals 16.78 million colors. Or
Lots
72.
Yeah.
Which sounds like a lot of colors.
It is a lot of colors.
Until we got to 10-bit.
Right.
Now, where does this come into play? Banding.
Yes.
When you're looking at a picture, let's look at his shirt.
Here.
I'm going to pick on his shirt for a second as he steps away.
And this. Okay.
There's his shirt. Now, his shirt is in theory one color of red.
Right.
But it's not.
Nope. We
perceive it as thousands of variations of that red.
Yes.
Because that's how we see the 3D-ness of it.
Right, because my eyes looking at this, they see a slightly darker shade.
Right.
That looks like a shadow, which then gives it a little bit of a
It
depth.
could be light reflection, could be a surface reflection, could be anything affects that.
Yeah.
So if we've got 8-bit color, we're only gonna see 16.7 million total color options.
Right.
Black, red, everything combined.
Yep.
Now when we add this to this, so get out your calculator.
All right.
So
let me give you your top-down shot again.
When we're at 10-bit, what are we at?
All right, let's see. So let's get our calculator out here. So we're at 256 here, right?
Which gives us 16.7 million because it's 256 times 256 times 256.
But
here,
at 512, it's
where do we actually at?
So 512 times 512 times 512?
No.
No?
What does all this add up to? Not the last number. All these numbers add up to what?
1024.
Exactly.
Yeah, so 1024
times 1024 times 1024.
And it's not 1024 times 3. No, it's 1024 times
1024 times 1024.
It's cubed because we have that.
Right.
Yes. Equals, let's see, 1,000 million, 1,073,741,824.
That's a long way from 16.7 million colors,
right?
Isn't it?
Yeah.
Now, you actually asked about 14-bit.
Yeah, so actually with 14-bit, we jump up another...
We had 2 more. We had 1024.
We had 4 more. We're at 10.
Right.
Right.
So you add 1024, 2048, 4096, 90... it's vapor locking.
9180... No, 9192.
Okay, so basically you're at 92.
Let's see, 512... 1024 plus 1024, so that's let's see, 1024, 2048. Yep, okay. 2048 plus. Look, I'm doing math again. I said it wasn't going to be a math episode, and I'm doing it again.
I think you're doing it the hard way, but
I am. 8192. 8192.
Okay.
Okay.
So let's multiply 8200 times 8200 times 8200.
All right, 8192 times 8192 times 8192. 1,000 million billion. Billion. It's still in the billions, but it's 500 billion. 549
for
billion.
14-bit.
Yes. For
16-bit takes you into trillion.
Yes. Again, I'm not going to do the math anymore because we're going to get. I'm going to get in trouble if I do the math again.
Years ago.
Did you? Yeah.
Yeah, I had a spreadsheet for it, and I couldn't remember the numbers.
Maybe I'll have to add that to the bandwidth calculator.
But the bottom line is this.
Right.
Color depth is very, very critical. In fact, for me, color depth is more important than resolution.
Right.
Because you reach a point where the human eye cannot see the pixel structure.
Right.
And at 4K, we're pretty much there.
Yeah.
So one of the things, and you and I talked about this on the previous episodes, on the math one, is I would rather see more colors for less banding.
Yep.
Than higher resolution.
Yeah.
The other thing is, particularly if you're watching sports, the higher the refresh rate, the smoother the motion. And as we know, because we set up the LG,
yep,
which is currently not here,
yep,
to do 120 for the gaming.
Yes.
And it was an obvious improvement. It wasn't, hey, that's nice. No, it was, wow.
Yeah. Well, because here's the thing, we're kind of we're reaching the end of the human eye capabilities, right? So it's at least especially with resolution, I think we're reaching the edge of that.
Usable resolution.
Usable resolution. But I also think that we're getting to the point where we now realize that, and so now we're turning it towards the other aspects of the human eye and what it perceives. And so now we're getting into better bit color depth. We're getting it better into HDR for the light capabilities.
And that's something else. It's when you look at HDMI 2.1 as part of the feature sets, is dynamic HDR.
Yes.
Now, HDR is metadata, so it's not really eating up bandwidth.
Right.
But it is eating up processing power.
Yes, and that's where that's where the TV. So that's that's fun. So it's not so much eating up bandwidth because again, it rides in the overscan, which is always there, right?
It rides in the sprocket side of the film.
Sure. Yes. Yes. Almost. It's like right up against it.
Overscan,
right?
Yeah,
it's like right up against it.
It's not in the visible portion.
Correct. Yeah. So then but you're right, because the processing power to read that quickly and to use it on sometimes in a frame by frame basis, which not very often, but it can in a frame by frame basis use that information, especially with like HDR10 Plus and Dolby Vision, because those are dynamic HDR systems. When you look at the idea of, well, why would I need to upgrade the TV to a better processor?
Strange you mentioned that, because our LG died.
Yeah.
And tech comes in, service department comes in Monday? Yesterday. And they take the back off, and we're watching this surgery going on, and it's like, look at the heat pipes.
So yeah, if anyone has ever seen, and actually you took a picture of it, didn't you?
I did.
Don't worry about pulling it up. I'll put it up on Instagram later.
But it's awesome.
So when you look at the insides of this, if you've ever done any kind of work on like laptop computers, or even desktop computers that are like the smaller kind,
ones.
Well, the heat pipes. It's no longer just a matter of just having like a fan on like a big hunk of aluminum or anything like that. They have to sometimes move that heat to another area so that there's better airflow for it, especially on like a laptop. And so you have these heat pipes, and I was nerding out about the heat pipes and how they work because it's fascinating. It's fantastic. It's a completely sealed tube of copper with a wicking material on the inside of it, and then a coolant inside.
It treats it like convection.
That treats it like convection. Over the CPU, it heats up and it gets turned into a gas. And so because it got turned into a gas, the pressure of that forces it away from that location. It gets to the other side where the cooling system is. The cooling side turns it back into a liquid, and then the wick pulls it back over to the other side, and you just create this convection system, no moving parts or anything like that inside of there. All that to say, that was inside of the LG TV that's generating all this heat from the processor. So before, we used to have like the plasma TVs, where the plasma TV portion to it, the actual panel, was producing all this heat because it took a lot to actually make it happen, right?
Right, because you were having to charge all of that plasma gas.
And so now it's no longer the fact that it's the panel itself, it's now the processor inside of there, which is super powerful. It's one of the A9 chips that's in that one, because I think this is the
it is an A9.
The Nano 80 series, I think is the TV that we have back here. But it's an A9 chipset that's in there. There's actually two chipsets in there. There was two heat pipes coming from two separate locations going to one cooling location. So whatever is the second one, I don't know. I want to find out for sure. That it's probably some kind of ARM processor for something else. But all of that in there is generating all this heat. So when you have a client that says, oh, it's not super important for processor, it's a TV, what does it matter? This is why. If it's better able to handle that.
While we're on that point, let's talk about current draw on fiber cables that are working in the 8K domain. And why do we use two power supplies on our 8K fibers?
Well, because of that simple fact that I think, honestly, we're beyond the point now where TV manufacturers, especially when we get into 8K and better 8K TVs,
even 4K,
it's not even so much that they're cutting back on the power supply.
The spec doesn't require it.
They need to use the power that's there for their own CPU in order to run it better, and so they don't just put like a bigger power supply in there in order to cover everything.
And what he's talking about is the way HDMI works is the display side of the system powers backwards to the previous device, a source or an AVR.
Yep.
And if you have an active cable of any type, whether it's copper or fiber, it's also drawing power off that bus.
Right.
And as bandwidth increases, the TV requires more, as does the processor in the active cable.
Right.
Which is why on our detachable head shell and our 8K cables, we include power supplies, and on the 8K, we require 2 power supplies.
Right.
Because there's a lot going on in there.
Yep. Well, because you've got the VXLs inside of there that are converting the electrical signal into light
really fast,
and then they're receiving it on the other side and converting it back into electricity. So not only do we have to convert the electricity to light and move it really, really quickly, there's a door opening and closing extremely quickly
for 3 channels.
If you go to your house, grab one of the doors and open it as quickly as you possibly can, you're going to get tired really quickly, and also your wife is going to yell at you.
Now, by the way, that also is a damn fine example of how eye patterns work.
Yes.
When you're moving slow, you have time to open the door all the way and close the door all the way.
I think this.
As you increase the speed, your movement will start to shorten.
Right.
So you don't get the full swing because it's impossible to get it all the way open and get it closed.
Right.
And by momentum in the time frame.
Michael Heist is saying that the Sony F55 can do 16-bit RAW. And the Red Monstro? I don't know
if camera?
If that's a typo. Yeah, Red is a camera. I think the F55 is also a camera.
Yes.
So, recording at 16-bit is definitely important.
How big a drive do you need for that?
Well, that's one of the big problems. Yeah, exactly. It's all completely raw. Like for instance, the camera that we use here, it's a 4K,
which is the Blackmagic.
Yeah, and we actually are not recording raw
because it eats up too much space.
It eats up too much space, and we're not recording 4K. We're recording 1080. Although that's because of the stuff over here. But the thing is, though, is that if you can record at a higher bit depth, you have more range to work with in order to dial it in.
And what we're seeing with the Reds, particularly the 8Ks, is they're starting to film in 8K for 4K applications because now they can actually move around
within
the
the frame
field
Yep.
and not have to move the camera.
Right. Yeah.
Which is awesome, so they can maintain a very high resolution.
Yep.
They're not having to do it with lenses or faking it.
Yeah.
So they can just film a wide area and then in post-production say, this is the area that I want for this scene.
Right.
So we're back to data.
Yes.
So talking about bandwidth.
Yep.
This is where 2.1 gives us more capabilities for resolution and bit depth.
So to circle it all back around, everything that we've talked about so far has been the additive features, right? These are the things that are adding more bandwidth requirements to the system, right? So before with 1080p, it was 10 gigs roughly, and then from there we went up to 4K, which it wasn't.
The original format was 5.
Right.
Then 10.
Yeah.
Then 18.
Yeah. So with 4K we have 18. Now with 8K or with HDMI 2.1, it's better to reference it that way. HDMI 2.1 is a set of features within a certain set of within a certain bandwidth. I think that's probably the best way to define that, because with HDMI 2.1, the spec is spec'd for 48 gigs. Now, Brent, what are we getting right now?
40.
Because we're not getting 48, right?
Because there's really not consumer available.
Right, and we've had this conversation multiple times, and I don't want to get too far into it, but yeah, that's the main thing. They just don't have...
Hand me the trash can.
Uh-oh.
Hand me the trash. This is HDMI 2.1.
Yes.
How much stuff can we put in this? Well, let me tell you. I can put this in there.
Yeah.
It fits.
Yeah.
This is 8-bit.
Yeah.
I can put this in there.
Sure.
That's
HDR.
40, yeah. Can I put...
Oh, boy. Now, don't grab something that we can't show.
Can I put this in there?
By itself?
No, without compressing it.
Yeah.
No, without compressing it.
Yes.
So this exceeds the capabilities of that.
Right. So that's where we come into these subtractive features, right? So now we have, we talked about the resolution, we talked about bit depth, we talked about the others. Now we get into the things that are subtractive. We talk about chroma subsampling. That was one of the early ones with HDMI 2.0, was the chroma subsampling. That's the 444, which is
422,
422, 420. 444 means that every single pixel gets its own piece of information.
Which 1080p supported.
Yes.
Because it had no problem.
Well, yeah, and it used it. Yeah. But with 4K, we realized, we're starting to run out of bandwidth, so let's go ahead and use that. That cut down on the bandwidth by quite a bit, up to 50%. Or if you look at the math on the calculator, it's 0.667 percent.
Two-thirds.
Two-thirds. And then also you have, now beyond that, we have other features that they've added on into HDMI 2.1. So one of the big ones, of course, is that we now have, for gaming especially, is variable refresh rate.
Which is an awesome feature.
Right.
And we've actually played with it here.
Well, we've tried to. That's one of the problems that we've run into, because the TV, and actually that's one of the things that we want to talk about, the TV that we have does not, it supports 4K 120, no problem. It does not support variable refresh rate. And what variable refresh rate means, when you're playing a game on a PC or on a console or something else, the graphics card that's inside of there is doing a lot of, is rendering everything that's happening, and then it's outputting that render to the display on the fly. Now, what happens though is that if you look at something, if you talk to Jessie here, she'll say if you look at this room, there's a lot of stuff in this room, right? And so in the game, if I were to make this into the game,
when I look at the video screen,
looks nice and clean, right?
It looks nice and clean.
So what you all don't see is the mess that's off camera. Now in a game, if you have a lot of stuff on the screen that has to render individual parts of something, it takes that machine a lot longer to render everything, and so it can't render all of the frames up at the 120 frames per second speed, or higher depending on if you're on a PC doing something else.
So make sure I understand this. As we increase the objects on the screen,
yes,
in order to maintain the processors within the processor's power, I have to decrease how fast the refresh rate is, because now there's more individual objects of unique characteristics to render.
Yes. So the best way for us to understand that is then to take that the information of, say, 4K 60, that's too high of a bandwidth. Let's just say it's beyond the 18 gigs, it goes up to 24. Let's say then that we say, okay, well, instead of 4K 60, we're going to drop it down to 4K 30. Now, the difference, though, is that 4K 60 is a locked number, and 4K 30 is another locked number. Variable refresh rate is variable anywhere in between 120 frames all the way down to, I don't even know if it has a bottom or not.
So it's tracking actual bandwidth output and adjusting what it's doing to stay within the roadway.
So there's communication basically what happens is the source device, the game console or the graphics card inside of a PC, and the TV during the EDID handshake or the EDID communication, what's happening is they're both saying I have variable refresh rate. If they both have variable refresh rate, they turn it on, and as the graphics card inside either the game console or the PC is outputting information, the TV is looking for that information. So before, if it lost a frame, the TV may just show a black frame for a second. Now, if it lost a frame, the TV slows down and just keeps the last frame that it had and shows that instead. That's essentially what's happening. There's a lot more that's going on, a lot more communication that's happening, but variable refresh rate is like that. So here's the thing. Why is it a subtractive feature for bandwidth? Because now I'm cutting back the bandwidth that's being used. Now, it's not...
I appreciate you letting me answer that one. Thank you.
Well, sorry, I'm running with it. So one of the things that they'll do, that feature though, however, is not built specifically to lower bandwidth. It's built to accommodate a higher bandwidth video stuff that's happening. So it's a subtractive, but it's more like it's right in between. It's right in the middle. It doesn't add anything. It does remove stuff, but it's not doing it for the sake of lower bandwidth.
As we're playing a game, and I got a ton of stuff on the screen, and now that's having to be rendered. My machine determines, you know what, I can't maintain this level of speed with this many objects.
Right.
Is it visible on the display?
It's not something... anybody who does PC gaming already sees this a lot. It's been a standard in DisplayPort for quite a while. NVIDIA graphics cards have their own version of it. AMD has an open version of it. But the way that it works is that it doesn't necessarily tell you, specifically that, hey, I'm slowing down. Instead of 120 frames, I'm now at 116 frames per second. It doesn't do it like that. It's more just on the fly. So if you take the camera and you pan over in the game over something that has a lot of stuff, it just starts getting slower, and you may notice if it gets way down, you may start noticing it's a little bit choppier than it was before. And then if you move away, if you move away from all that stuff and look at like a blank area, now it goes back up to 120. Yeah, it goes nice and smooth. So that's basically what's happening with variable refresh rate.
And they do the same thing with color. Because if there's a ton of color, they can also adjust the refresh rate there too.
Yeah, again, if it's too much for the graphics card in either the PC or the console to render everything, whether it be because there's too many objects, too much color, too much whatever it is, the graphics card can't keep up with it, and it just cuts back. Rate. Exactly, yeah. There was actually a problem recently where Amazon released a game that.
Amazon?
Yeah, Amazon released a game. Well, they hired a studio to release it for them. But they released a game. One of the problems with the game is that there was a part in the graphics card that's supposed to act as like a flywheel, or not a flywheel. It's supposed to act as like a governor, so it doesn't go too high for the frame rates. And so they actually there was a flaw where they could bypass that. And so they're actually breaking people's graphics cards because it jumps well past whatever it completely burns. Yeah, exactly. So that's what
has a nervous breakdown.
Right. So with VRR, we don't really have to worry about that because it's 120 frames is the max, and that's it. That's all the further that we're going with it. And so it locks it into that.
Under 2.1.
Under 2.1.
As we currently set.
Yep. And so that the TV gets the information from the graphics card on the fly as the graphics card is releasing it and sending it to the TV. There's not really any kind of communication saying, "Oh, slow down." No, it's not saying that. It's just here's the information. Here's everything that's coming to you.
Right. The TV just knows to adapt as it's coming in.
Right.
Okay, so understanding that, another feature set that's very important under HDMI 2.1 is link training.
Yes. So link training, do you want to take that one?
No, you're doing a great job. Okay. I'm just going to stand here and marvel at your magnificence.
So long as it's not math, I'm okay. Okay, so...
If I still had it, if I had a chair.
Yeah. So link training, the way that link training works is like this. So it's very similar to variable refresh rate in that it cuts back on the bandwidth.
So it's a subtractive...
It's a subtractive. However, it's designed specifically to make older or not as good HDMI cables work okay.
So, and the reason for this is plain and simply, stores don't want TVs, sources, and cables going out and coming back.
Right.
For whatever reason.
Right.
So by adapting, and it still says 8K on the TV.
Right.
It just isn't quite the 8K you thought it was getting, but they determine most people can't tell the difference.
Right. So when you look at the link training, the way that works is basically there is communication happening. Now, the source device will do the handshake for EDID and for HDCP with the display. The display says, "Yep, I'm here. This is what I'm capable of," and then they start sending data. Now, what will happen is that the source device will start sending data, and the TV is looking for, or the display is looking for, the information that it's sending. However, if it does not get good data as it comes in, which means like pixelation or
bad eyes,
bad connection, bad whatever else, what it'll do is the TV will say, "Wait, I'm not getting the correct information. Let's go ahead and back this down from 40 gigs, or if we ever get from 40, it'll back it down to the next one." Now, the reason why 40 is important is because that's one of those stopping points. So we go from 48 to 40. The TV says, "No, I'm not getting all the information. Let's back it down from 48 to 40. And it's not like a variable to where it's like it can go in between and say
it's fixed at that point.
It's fixed, yeah. From there, from 40, it can do it again and say, "No, it's still not coming in right. I've tried all the different equalization curves and everything else to make this work. Let's go ahead and back it down one more step. Let's go down to 32. And that's why it's important that the PlayStation 5 is at 32 gigs. So for everybody who's seen us talk about it before, most displays and most sources out there, whether it be a PC graphics card or the Xbox, are at 40 gigs. Meridio has their test pattern generator, the 6G and the 6A.
That's at 18. The 7.
No, the 6G, the new 6G is also at 40.
Is it?
Yep. Now the 7 is also 40. However, that one can do a lot of stuff that the 6G can't. However, theirs is also at 40 gigs.
Right, because that's the available
chipset. Now, the Sony, the PlayStation 5, it is actually locked at 32. Now, that's another one of those stopping points. So after 32, if it still can't do it, it goes down to 24. And if it still can't do it on 24, it drops into TMDS 2.0 domain. Now, here's what's interesting. If you watched that episode 2 weeks ago where we talked about bandwidth, you can still get 8K under TMDS standards of 18 gigs.
Which I said at the beginning, and you looked at me like I was crazy.
Yeah, well, you can. Yeah, it's the thing is that it's running on TMDS. It's not running on 2.0. It's just running on TMDS 18
Inside
gigs.
of the 2.0 standard.
Right. So, with all of that said, that's a specifically designed subtractive feature.
As is display stream compression.
And that's the next thing. So, there's a difference between link training and display stream compression, right?
Because link training just drops your overall quality as an option.
Right. Now, here's what's scary about link training. Let's go back to that really quick. Link training may or may not tell your client in the field that it's doing it.
Well, of course they're not going to.
Right. They're going to turn on their TV, and up in the corner it's going to say 8K, 60 frames per second, or 30 frames per second, or whatever it is. They're not going to tell you that, oh, we've done chroma subsampling to knock that down. We've dropped color down. We've gone lower bit depth. We've done this. We've done that. We've done this. We've done that. Until finally it's compressed all the way down into a lower bandwidth to where it can actually work. So that's one of the things that you got to watch out for. If you see your client is like, wow, this doesn't look nearly as good as I was expecting it to, take some time, put a good HDMI cable. We recommend ours, of course. Put a good HDMI cable with the source device closer to the TV. See if that makes a big difference to it. It probably will. And you'll notice you may or may not notice anything. A lot of clients are not going to notice a single difference.
As long as it says 8K in the TV,
they're probably fine.
I mean, let's face it, a lot of people bought Bose AMS systems.
Right. No highs, no lows. So am I allowed to say that?
Say what?
Yeah, exactly. Okay, so display stream compression. Now,
we like this.
We like this a lot. Display stream compression, however, I need to take a drink. I'm going to lose my voice.
I'm enjoying this week. I am disappointed I don't have a chair.
So, display stream compression, the way that works is different. So, Brent, have you ever needed to send a large file from one person to another, or make a file take up less space?
It's just trying to get a file through our email system.
Well, yeah, that's firewall.
Yes, you use some kind of zip format.
That's HDCP, is what that is. That's that problem that you're running into is similar to HDCP. Yes. So
you have to zip it somehow.
You have to zip it. You have to compress
RAR file or zip file
right.
or something of that format.
Right. So the way that display stream compression works, and I'm not going to get into actually how it works, but essentially what it does is it takes rows of pixels, and it takes the data for that row and compresses it down into a much smaller section, and then it moves to the next row and it does that, and then it decompresses it. So the way that it works is it says, okay, here's all this information. I feel air conditioning.
That is a thing with your imagination.
Or I'm losing my mind. So the way that works is the display stream compression captures the data before it leaves the HDMI port, right? So the source device renders whatever's happening. It sends it over to the display stream compression chipset. It takes that data and it says, okay, we're going to shrink this down because this red next to this red can be shrink down to, say, red squared or red 2 or whatever it is. That way they can take all that information and cram it all the way down and say, okay, here's 6 pixels of red at whatever value. They're the same value, so we're going to shrink that down to 1 red times 6, right? Then they take all these are super basic terms for the way that this works. There is some documentation online for a white paper on exactly how it works, but it gets really in depth into like the math and everything and how it works there. However,
and we don't do math.
However, basically what happens is it takes the data that's happening, compresses it down, and then transmits it across the HDMI cable. And so the way that this works is that it's able to say, okay, these pixels next to these pixels are the same pixels. We're going to compress that down to say, this is just 1 or 2 pixels, right? And so then it sends it across, and on the other side, it goes to the display stream compression receiver chipset, which then takes it and uncompresses that back into its original state, and then displays it on the TV.
Now, the reason we like display stream,
you did it too, right?
Wow.
Say that 10 times fast.
Yeah, is when we did side-by-side comparisons between a proper enabled display stream system and fiber on a 65-inch HDR loaded up TV.
I was looking to see if I had one back here.
We were not able to see the difference.
No.
Which was the first time we could say that we were not able.
Right.
So we were super excited and stoked about that.
And that's actually one of the ways that our 120 meter extender works, is we compress the data first, then we send it over HD-base T, which then HDMI decompresses it on the other
side.
side.
So we're taking an HDMI 2.1 feature set and employing it in the 2.0 domain, which, by the way, is exactly what eARC is.
Yeah.
eARC is, in fact, an HDMI 2.1 feature set that can be deployed on the HDMI 2.0 data bus.
Yes.
Which is awesome.
Yep.
And there are other things in there. There are things that will work on both of them that just were enabled with HDMI 2.1 because they were thinking about 2.1. So all this aside, how do we design a system and plan a system for 2.1?
Okay.
And by the way, we are now at 55 minutes and 50 seconds.
Yeah. Well, we're at 47 minutes, so we're right at the end of it.
Well, next week.
Here's the thing. The reason I wanted to get all that stuff out there in front of this is because once you know all this stuff, we're not. There's actually quite a bit more. Once you know all this stuff that HDMI 2.1 has available, then you can go ahead and take all that and start putting your Legos together and building your system.
The tough question. Do we have anything planned for next week yet?
We do.
Is it up?
It's up, but we can reschedule if we need to.
I think we need to continue this on for next week.
Okay.
Because there's still stuff we need to talk about and what HDMI 2.1 is.
Okay.
And what it's capable of.
Okay.
We haven't touched on audio formats. We really haven't even got into comparing, okay, what does 4K versus 8K look like? And why are refresh rates so important in both?
Yeah.
Because I would rather see 4K 120 than 8K 60.
Okay. So let's do this then. We've got 10 minutes?
Okay.
10 minutes? We've got 10 minutes to go ahead and tell you how to design an HDMI 2.1 system.
Wow.
You ready?
By fiber.
Okay. Well, yes, but that's okay. So here's how. And actually, I'm gonna tell you what. You got $5? I'm gonna bet you $5.
Hold on. I have to my name $52.
$52.
You want the 10 or the 2?
I'll bet you 2. I'll bet you $2 that I can explain how to build an HDMI 2.1 system in under 10 minutes.
Okay.
You ready?
I'm game.
Okay.
Hold on.
You got your timer?
Hold on. If we're gonna do this, if I'm putting my $2 out here.
Yeah. Oh yeah. No.
Because you have forced me to put my $2 out here.
Oh yeah. I'm ready. Let's see if I got $2 in here. Hang on. Yep.
Okay.
Yep. All right, you see my $2, right? You see my $2.
This is going to be a real description. This is not going to be my example of buy fiber.
Yeah. Yeah.
You're going to say buy fiber, but VLOX.
No.
Okay.
No. Okay.
Go.
So the way that this works is this: you're going to buy one of 3 products that are out in the market for your source. You're either going to buy a PC graphics card from the new series, either an NVIDIA graphics card or an AMD graphics card. You are then going to buy a VLOX HDMI cable, whether it be a passive HDMI cable or one of our active AOC fiber cables. Then from there, if it's an active cable, you're going to make sure to power it. From there, you're going to go out and buy one of the thousands of well, maybe not thousands yet, maybe the tens of HDMI 2.1 capable displays.
Now, is that tens in model numbers or tens in complete existence across the U.S.?
Let's do model number. Well,
okay.
I mean, yeah, depending on how you talk about it. Then you're going to take all of that and you're going to connect it together with the HDMI connection, and you're not going to use any kind of extender. Okay, let me back up. If you now want to add in a surround sound system, you're going to go out there and buy one of the non-existent AVRs that no one has available right now. That is 8K capable with HDMI 2.1 on. No, it's not 8K. It's HDMI 2.1.
Right.
Right, because 8K is not necessarily the only feature set for HDMI 2.1.
Yes, we discussed earlier.
Right. So you're going to take that. You're going to take a passive VLOX HDMI cable, which we offer. You're going to take your source. You're going to plug it into your AVR, which is 2.1 capable. Now, if you are using
port
into the 2.1 port, if you are using a Xbox or a PC graphics card and you are using it with a Denon or Marantz AVR,
you're going to get the outboard piece.
Get the outboard piece,
unless
or
it's got the most recent firmware update.
Not the firmware update, because it was a hardware update.
Change.
Yeah. So if you have one of the new AVRs that says that it's got the update or has been changed and everything, reach out to your rep for Denon and Marantz if they have that available or not. Again, if they have any AVRs available right now, is one of the big questions of that. But after the AVR, you're going to use our AOC because assuming you're going a little bit of a longer distance, you're going to use our VLOX
integrator.
Right? You're going to use our VLOX fiber HDMI. You're going to plug in the source side of the HDMI cable into the AVR. You're going to plug power that is included with that cable into a wall outlet or into a power strip or something else because it needs its own power. Do not use the USB connection on your AVR. Right?
Right.
Right, I'm only at 2.5 minutes.
Okay.
From there, you're going to run that cable over to the display, and you are going to plug it into the HDMI 2.1 input of your display. Now, this is assuming that you've done your research and found out that that display is capable of 40 gigs, or that it's a 2.1 capable TV.
Or that it does what your gaming system wants it to do, which, as we have found,
yes,
a lot do not.
You may find that there is a 4K 120 display that doesn't do 8K, but it does do variable refresh rate, or vice versa. You may find an 8K TV that does 4K 120 but does not have variable refresh rate. LG. So you're going to hook all of that up to the TV. You are then going to turn everything on. Once everything is turned on, if you get a black screen, you're going to cry.
Because that's what we did.
Because that's what pretty much everyone else that has run into with it. When you get the black screen, you're going to bypass your AVR. You're going to run it directly to the TV, and you're going to find that it's going to work. Again, link training will kick in if it needs to. Now, in most cases, it won't need to, especially if you're using our VLOX cables, which are capable of
48 gigs.
Thank you. So at 48 gigs, actually, I do owe you $2 because you've given us too much information.
Is that Michael?
You've done. Yeah, it's Michael. It's the experts.
Oh, okay.
Yeah.
Then I'll give $2.
Yeah,
Michael will give the 22.
Yeah. So once you have everything hooked up and you're done crying because it didn't work through the AVR, which again, listen, I did it myself because it needs to work. So once you have everything hooked up, you go ahead and play some games. You realize the 120 hertz looks amazing, and now you want to become a gamer. And that's how you hook up that's how you design a HDMI 2.1 system.
So what about matrices? What about extenders? What about multi-room distribution?
I did say don't use extenders. Don't use matrices because there is no matrix. I take that back. There is one matrix on the market right now.
Is there?
Yes.
Okay, you're ahead of me on this one.
Our friends over at
do they?
Yes. They just announced it a couple weeks ago.
Is it shipping or is it announced?
It's announced. I know that much.
Okay.
I don't know about the other. So anyways, not to advertise our competitors. But all that to say, if you do need to do some kind of distribution, that's where things get tricky. Because now we run into things like ARC and eARC. So let's say, for instance, you've got your Xbox plugged in directly to the TV. You got your new AVR that's capable of eARC connection to it because you've got your surround sound. The best way to connect it at that point is take your Xbox or PC or PlayStation 5, plug it in directly to the TV, take the eARC output from the TV back to your AVR. So remember, eARC is using the HDMI input on the TV and it's using the HDMI output on the AVR.
Now, how far can you go with this?
Where are we at, 10 meters?
10 meters.
10 meters. At 10 meters, because eARC does not travel down an active portion of the cable. It's a passive portion.
It travels down the copper.
Right. So you need to make sure that you run that back down, that connection back to the AVR under 10 meters. For right now, run it down that.
There are solutions coming.
There are solutions that are being worked on and hopefully coming soon. So once you have that all run back to your AVR, then you go into the settings of the TV. Now, in most cases, the settings on the TV. Why did that
you
stop?
Just turn the timer off?
No, I didn't. Your phone locked up. So you go into the settings of the TV, make sure eARC is turned on as a feature, and go into the AVR, make sure the AVR eARC is turned on as well. So long as you have all of that turned on, everything else is handled by EDID and the communication between the two, and it's actually handled over CEC. So, unfortunately, you don't turn off CEC. If you turn off CEC,
many things change now.
It's not going to work. So,
and why they're using CECs, they ran out of space on EDID.
Right. Actually, that's a really good question. The experts ask, is the HDMI 2.1 input the same as the eARC input? In most cases, yes.
Okay.
Because in most cases, the 2.1 is or eARC is a 2.1 feature. Now, in the cases that it's not, because it's so here's where it may not be.
I don't see a chance of seeing an eARC terminal on a 2.1 TV that's not a 2.1 input.
Yeah, the only way that could be the case is where you have an HDMI 2.1. You only have one HDMI 2.1 input, and so they don't want to use up that input for
I don't know of
that
anybody
connection.
doing that.
I don't know either, but it should be the same input. If it's not, look at the settings on the bottom. Look at the inputs on the bottom of your TV. Call the manufacturer and find out from their tech support.
And
reach out to their tech support because granted, we are different tech. We are a different type of tech support than their tech support is.
Tech
but
support is excellent.
yeah, reach out to their tech support. Look at the back of the TV where it should be labeled. Now,
And
again,
I will say, not interrupting, we put the timer on pause for a second because I want to be fair about this.
yeah. I think I've made it right.
Not yet, but
Am I missing something?
I don't know how to pause this. But one of the things we found trying to get a new 4K or 8K 120, 4K 120 TV
Yep.
is finding that specification
Yeah.
was not easy. In fact, for one of them, we actually had to look in the manual because it wasn't on the web page spec section.
Yes.
So this data is not easy to find.
Well, and that's what it was. It said, yeah, it's 120 hertz, but it didn't say 4K 120 hertz.
Right, so it could be 1080p 120.
Right. So
there's
definitely look up
as
that.
we both know, there's a whole lot of hide the baloney and misrepresentation.
Right.
Marketing.
Yeah. Cheap lie.
Cheap lie.
Cheap lie. And that's how you design an HDMI 2.1 system. Luckily, right now it's very easy because there are a total of 3 sources out there that are HDMI 2.1 capable.
Oh no! The Apple TV is halfway there. It does have an HDMI 2.1 port.
It's just not.
It's not turned on really yet.
Okay.
And we honestly do not know
So really,
if they can turn it on.
well, here's what I think is happening there. I think it is turned on. They just aren't using. They're just. If you go into the settings of like the Xbox or the PlayStation or whatever, and you say, don't use 4K 120, use 4K 60. It's just a settings change. I think that's what they're doing in the Apple TV. I think they're just basically saying you don't use 120, and so it's there and it's operational, but it's probably not actually using that setup yet. Hopefully, it'll just be a firmware update, and all of a sudden now we have
Boom.
what we need. So, have I earned my $2?
You earned your $2.
I have earned my $2.
Congratulations. Here, since we're
Yeah, there we go. So, everybody, that is how you design an HDMI 2.1.
any questions? Any?
Ooh, really? Is it? The new Google Chromecast.
Who's that from, Michael?
Yeah, from Michael
Okay,
Hines.
I'm going to give that one credence.
HDMI 2.1. Really?
Another new thing to buy.
Yeah.
Okay.
It's the Google Chromecast with Google TV. Specifically that one. That's the one that comes
that's
with
a
the new
new look.
remote. Yeah, it's a new look and it's a new remote.
Okay.
Yep. Interesting. We'll have to look that up.
Thank you, Michael.
Can do it, not necessarily that. Well,
Much like the Apple TV, it has some inherent abilities,
yeah.
whether or not it's turned on yet.
right. So, and it may be something like the PlayStation where it won't get above 32
yeah.
or 40 or something like
And
that. So
that could be them protecting their processor until they have better time in field.
yeah. So we are now at 1 hour. I think at this point in time, I think what we need to do is go ahead and wrap this one up because a lot of information for HDMI 2.1.
Yes. Now, what are we going to be talking about this Friday?
So because we're talking about HDMI 2.1 and its capabilities, we want to talk about our products that are HDMI 2.1 ready.
And are capable of 42, 48 gigabits right now.
Right. So come back this Friday at 3 p.m. Eastern time where we will go live. Are you going to be on this one with me?
Yes, I am.
Okay. We'll be live again this Friday, 3 p.m.
Are you going to be on this one with me? You may be working on show stuff.
I will be working on show stuff. That is right. You may have to do that one by yourself.
Wow.
Yeah, that's frightening. Huh? Did I say that?
I
Anyways.
truly appreciate the love and support I get in this studio.
Everybody, thank you again for checking out today's episode. If
And
you have
listening to him.
Yeah. And yeah, thank you for listening to me ramble on about HDMI 2.1 and how freaking cool it is. Look, we whine and complain and groan about HDMI 2.1 and what they're doing with it and how it works and all that kind of stuff and the problems that we're going to run into it.
It is awesome.
But it is really cool. It's really cool. All the things that we've been saying for a while now. 4K is great. 4K looks good. Anything greater than 4K, not really interested in. But better frame rate? Yeah.
Better color depth?
Better color depth? Yeah. HDR?
Yeah.
Dynamic
And
range?
Dynamic HDR? Yeah.
Yeah. So
it is absolutely, it's amazing what's coming up here. And the reasons for these things, the 8K is, But the 4K 120, the higher bit depth for color.
Yep.
I mean, how would you not want billions more colors?
Right. So the experts are asking, what show? Right now it's still happening. Right now we're still going. So maybe Friday we'll know more information.
It is, at a little after 4 on Wednesday. It's still happening, and we're still going.
And they haven't busted the door to tell us we're not going yet, so we're still going.
Yeah, they could bust the door and give us some AC.
We don't. Anyways, before I get in trouble for saying something I shouldn't.
Then let's sign off. I'm Brent.
I'm Adam.
Reboot early.
Reboot often.
Don't cut your wires too short. Yeah, you kind of lost on this and that.
Yeah,
Turn off CEC except.
Except if you're using eARC or ARC, and call tech support.
Call tech support, and we are tech support. Thank you.
Thanks, everybody. We'll see y'all next time. Check out this Friday. Check out next week's episode where we may or may not be talking about more HDMI 2.1 stuff.
Because we still got a lot to cover
Yeah,
here.
there is still quite a bit more that we should talk about with that. So thanks, everybody. We'll see y'all next time. Ooh, measure twice, cut once. Nah, we don't do that around here.
No. It's don't measure, cut many times.
Yeah, let's start over. Bye,
How many
everybody.
pieces of wood do we need for that one piece job?
See you, everybody. Earn my $2 today.